So the question is asking to find differentiate basically, yes. But in all the cases, what you will notice is that uh, you have to apply some versions of um, chain rule here. So um, the first one, f of x is arc sine. Well, remember, arc sine is another name for inverse of sine or sine inverse. And we know that the derivative of, it's a good review here to see what is derivative of arc sine x. Arc sine x, the derivative is 1 over root 1 minus x squared. That's just for arc sine. And then when you find the derivative, what is here, if you apply the chain rule, you notice that the inner function, you have to first differentiate the inner function. Then the outer function, which is arc sine, and it has this derivative, you have to write it. But wherever you see x, you have to plug in 1 over x squared. Okay. Or, well, instead of doing all this work here, you can use the chain rule with the derivative of arc sine, which is obtained by the chain rule, the generalized version, let me say it, but I most of the time will write as the derivatives with the chain rule version. So instead of x, if you have any function there, the derivative would be u prime 1 minus over root of 1 minus u squared, which both of them, you either apply the chain rule there or you use this version of the derivative of arc sine. So,
by the way, sorry to interrupt, but you need to square the inner term. It's 1 over x squared.
oh, yes. Sorry. Thank you. Yeah. Thank you. So here now I need to find what is derivative of 1 over x squared. That's it is x to the power negative 2 prime, and then this is negative 2 x to the power negative 2 minus 1, which is negative 2 over x to the power 3. So this will minus 2 over x cubed 1 over. This is 1 minus 1 over x to the power 4. And from there, you put minus 2 up there, x cubed there, and then find the common denominator. I just want to show you that you have to be able to do all the computations there and all the simplifications if it is needed. Minus 2 here. I can't separate this guy numerator and denominator and write it as 1 over x4 minus 1 over root x4. Root x4 is absolute value of x squared, but x squared is always positive, so I can write that one as this. Cancellation, this guy with that guy goes away, and the final is x4 minus 1. So these are typical simplifications that you have to be able to do, and if the question is asked in a multiple choice in a way that you have to simplify, you have to be able to complete that before you go to the next one. Okay. The second question, we have a derivative of the function is 5 to the power sine x plus x squared. Okay, so the rule here is that if you have the general base b to the power x, the derivative of that is going to be b to the power x itself, but you have to multiply it by ln of b. Okay. And well, the chain rule version of that, if you have b to the power something, then it will be the same as before, ln b b to the power u, but since u is a general function, chain rule says that you multiply the derivative of the inner function to the whole thing. So that will be u prime. Now, so in this case, we have the derivative of u here, ln b, the base is 5 here, and then 5 to the power sine x plus x to the power 3. Derivative of sine x is cosine x plus 3x squared times ln 5, 5 to the power sine x plus x cubed. And that's the derivative. The simplification is enough there. For the third one, we need to know what is the derivative of log in general base b. Okay, so let's first write the log x base b. This is 1 over x, and you have to multiply the denominator by ln b. And with the same idea of the chain rule that we always add to our differentiation rules, this tells me that the log of a function base b will be u prime over u, and then multiply the denominator by ln of b. Here, b is 5, so f prime x is going to be u prime, in this case, 2x plus 3 prime over ln of b times u itself. I'm not done because I still can see a prime there, so that means that I have to differentiate that, and that will give me the final answer that I was looking for. So chain rule and different versions of the chain rule, differentiation plus chain rule, you have to know.